Hey folks, welcome. You know, it's almost the end of another week. This fall is flying by. It feels like fall outside today also. I hope everybody knows how cool it is. And hopefully maybe that brings a few more of you inside. So you know what the deal is. Give us a call, 844-686-2378. I'm Ernie Roberts, and I am your host for Mathline this afternoon. We're glad you've tuned in with us. We thank you for tuning in. Now, what can you do for us? Give us some calls, all right? Let's have some call-ins today. It is a call-in show. One last day. Tomorrow we are not live, but today you have your chance. Give us some questions. Give us some problems. We'd love to work them out together live on the air. That's the whole plan. Got the phone operator waiting for you. That number, by the way, 844-686-2378. Dial it. Have fun with us. We enjoy it, and it also makes the show rock when you guys call in, give us some questions, some things that we can work on and solve out together and have some fun with it, all right? In the meantime, speaking of how much more fun can we have, let's go to our problem of the day. And it says, find the measure of a diagonal of a rectangle whose length and width are 20 and 15, and we're looking at inches for our units. That tells me the diagonal will also be in units of inches, all right? So let's see, find the measure of a diagonal of a rectangle. Everybody get on that? We know what a rectangle looks like. We'll remind you in just a second if you aren't sure. Whose length and width are 20 and 15 inches. All right, we've had some good Facebook action on this. Sharon, Mark, and David, all good ideas, good things. And you know what? They're looking at things from a standpoint of not having to do, well, we'll talk about it when we get there. All right, I'm jumping the gun here a little bit. We're using ratio rather than, well, like I said, we're going to see what a lot of you want to do. So there it is. There's your rectangle. Width, we're going to put as 15 inches there. It's a little bit shorter. This one is 20 inches. You always worry about high def. Does that make it still looks like a rectangle. It doesn't look like a square. Just want to make sure. Because sometimes high def stretches things a little bit. And hopefully it makes the stretch here on the more realistic. But we try to make this thing look pretty close to accurate, all right, when we draw these pictures with our computer graphics and such. But how is it going to work out for us here? We're looking for a diagonal, which we have not drawn in yet. By the way, before we leave on this picture, before we get started actually, let's put some boxes here. You say, what are those boxes in the corner? That means we got right angles because it is a rectangle. It is not just any quadrilateral. It's a special quadrilateral. It is a rectangle. And that, folks, is where we start. Now, a diagonal, we need one. So let's pull one in here. I always bring Curious George along for the ride on these afternoons. You all love him on PBS. You know that. Let's see what we've got going here. My goodness, there's the diagonal. And you know what? I could put a 15 right there. Because what I'm seeing here is, just look at part of it, it is a right triangle before our very eyes. Actually, two of them. We're only going to worry about the one on the left, or the bottom left, I guess I should say here, because it's going to work just as well. Now, mention I said something. By the way, these are inches also. I said we could do a couple of ways to get out of this thing. Some of you are thinking, oh, right triangles, that thing called the Pythagorean Theorem, yes, that's where we can go. That's what we can do. It's always fun. A squared plus B squared equals, you got it, C squared. And A and B are given to you, 15 and 20. We'll put them right in there. And then you've got the C squared hanging off here. So let's take a short look on this. I'm going to start first of all with A squared plus B squared equaling to C squared. That's what we usually think of doing here, putting some numbers in. Now, these numbers are starting to get a little bit big. All right, we got 15 squared here. We have 20 squared here, and something squared out here. That's what we're looking for. We'll call this C. You could also put a D there for diagonal X, whatever variable you want. But we always think of A squared, B squared, and C squared. There's nothing gospel about that. It's just three different segments, and they have to work in that order as long as you've got a right triangle. Doesn't work in any other case to equal out. So let's continue on here with this. This is going to be 225. Wow, this is going to be 400. And already some of you are going, Ernie, those are getting big numbers. They are. We add those up. I'm going to catch a 625 going on here. And now it is time, you know what? To get to C, it's time to get square root time. So we're going to square root both sides. Take the square root of 625. I'm hoping, because we have a 25 here, I think we're going to have a good deal. I think 25 is going to be our answer. Let's take it and see real quickly on the calculator. Some of you may already said, I knew the answer to that one. I tried it and it worked. So let's see what happens if we say square root of 625. And we'll press a big enter. It does. It comes out to 25. So our value, and by the way, that was what our Facebook folks all said today. They went with 25 as the answer, which is great. Now, some of them said they looked at this as looked at the ratio, 15 to 20, and thought about it. And a ratio, remember, like a fraction. So if you were to put 15 over 20 and reduce that, you get 3/4. So what we're picking up is a 3 to 4 ratio. And folks, if it's a right triangle, what's going to automatically fly with that is also 5. So we're looking at a nice extended ratio, which would be a 3, 4, 5. So there's a lot of ways to look at this. But you're going to say 3 times x, 4 times x, and then 5 times x. In other words, we're looking, what number did we multiply the 3 and the 4 by to get to 15 and 20? Well, we obviously did it by 5. So we're going to take this 5x out here. We're going to also multiply it by 5. So you say, wait a minute, Ernie, slow down a minute. Okay, how about it? 3 times 5, 4 times 5, and now what are we going to do? We're going to also put 5 times 5. And that's going to finish out our nice little ratio. You see we got 15, we've got 20, 25. It's a 3, 4, 5 family of right triangles, and it's a nice way to take care of it, all right? So in this case, there you have it. Oh, by the way, what is 5 times 5? It's 25. So it's an alternative way to do that. So there's your problem of the day, done 2 ways. And, some of you could have come up with maybe even more little fun ways to do that. But that's pretty much the idea in that case. And I understand, do we have a caller waiting for me?
Yes, sir.
All right. Welcome to Mathline, first caller of the day. And who am I talking with today?
Lucius.
How are you doing today, Lucas?
Good, how are you?
I'm doing well, doing well. What's going on in your world today?
I need a slope problem.
Need a slope problem, all right. And by the way, where are you calling from?
Knoxville.
Knoxville, Tennessee, great. What have you got for me? What is the problem situation that you got there? Can you give me what it is?
It's find the slope or the line passing through the point.
Okay. And I hope we've got some points there. What are the 2 points that you got?
-4 and another -4.
All right, -4, -4, great. And what else goes along with that?
2 and 5.
2 and 5. All right. Now, you know the formula, right? Is that usually you hear the 2 words rise and run. Are you familiar with those?
Yes.
So the rise is going to be my difference in y's, and rise and y's rhymes. So it's kind of a nice way to remember it. And the run is going to be how I do horizontally, so I'm going to be worrying about my x values. That makes sense so far?
Yes, sir.
All right, let's put some things in here. We're going to take, and I'm going to label these. I'm running, so let me pull it down just a little bit here. I'm going to call this my first x and my first y. See where I did that ordered pair style here? And then I'm going to call this one my second x and my second y. It doesn't really matter which one is which as long as I keep the numbers on the same point. You see what I'm saying? In other words, 1 and 1 go together, 2 and 2 go together, and those are our points. So far, so good?
Yes, sir.
All right. So again, I said if we're going to talk about rising, we're going to have to do the difference of the y's here. So I'm going to take y2. I'm going to use y2 minus y1. You could also say y1 minus y2 as long as you keep, again, the ordering going here. So I'm going to say this second y minus the first y, and we're putting it in the numerator. So far, so good? See what we got?
Sure.
Now, let's play it with the denominator. That means we're going to put the x's, and we want to keep the same order here. So it's x, the second x minus the first x. All right? That's what these little 2's and 1's stand for. They're little, we call subscripts, just saying, hey, first x, first y, second y, that kind of thing. So now, Lucy, it's time to put in numbers. And I'm going to go with 5 minus a -4. You see what I've got?
Yes, sir.
Now, I want to caution all our viewers too, because a common mistake sometimes people do on this is they just put 5 minus 4 because they see the -4 array and they just put that. And that's going to give a problem because what we're really having to do is say 5 minus that quantity. All right, and I'll put it in parentheses so it looks like, yes, we substituted it in. Now, let's go to your X file here, all right? You've got 2, and this time you're going to subtract also what? A negative 4? Is that looking good?
Sir.
And
Sir.
let's do these add the opposite moments here. This is a 5, and this is going to be plus a positive, right? And this 2 is going to go to 2 plus a positive 4. So all of a sudden I've got 5 plus 4. I bet you can tell me what 5 plus 4 gives you.
Do what?
I bet you can tell me what 5 plus 4 is going to give us.
It's going to give us 9.
Uh-huh. And 2 plus 4 on the bottom is going to give us what?
It's going to give us 6.
Yeah. And at this point, we've got an improper fraction, and that's okay. But what we do need to do is just simplify it down. We can see the number 3 is going to divide into both of these. So we're going to do that. And that is going to bring us down to 3 over 2. Does that work for you? Does it make sense?
Sir.
And since, even though, sometimes I know, what grade are you in, by the way?
8.
8th. Okay, so you all gotten to the point where you're not always so concerned about making mixed numbers, right, out of an improper fraction. And really, with slope, tells us a lot more than 1.5 would tell us. If we've got 3 over 2, that tells me we're going to rise 3 every time we run to the right 2. And that's the story on this problem, okay? Does that work for you?
Yes, sir.
All right. And thank you for calling in to us today, all right? We're glad to have you with us on the show and looking forward to hearing from you some more, all right? And enjoy the rest of your day and enjoy your weekend. All right, folks, it's that easy. You heard it. First caller, we're ready to go here. 844-686-2378. Let's get some more rolling in here. Yesterday, we left with a cliffhanger. We really did yesterday on the show. And we were going to solve for angle measures. Woohoo! All right, you say, what's that all about, Ernie? Well, what it's about is we had this problem that's kind of crazy. And those of you who weren't with us yesterday, you can go ahead and write it down here. Draw a quick triangle, a little extension off of this angle down here in the bottom right. And the numbers, well, we didn't get exactly numbers. We have some crazy variables, don't we? 46x plus 6, yaha. And over here we got 18x plus 4. And by the way, these little things are degrees. All right, we put a parenthesis around it and put a degree. Does not mean take it to the 0 power. We would have 1 and 1, which would make no sense. And, well, this would become 1 also, which would definitely make no sense. So, but this is 70x minus 2. Yesterday we established that we do not know this. If we knew this angle right here, the measure of this angle in some size, shape, or form, x would be easy to find. Because we could add up to get 180 here, or we could look at all 3 angles of the triangle to add up to be 180. But we have a missing link. And I also mentioned yesterday while we were looking at this problem, talking about the exterior angle of a triangle, which exterior means basically it's an extending of one of the sides. The ray goes here. And folks, this angle is supplementary to this one. That's what we got to call it exterior. Now, if you were to draw another line here, you'd have 3 of them there. One would be vertical, and 2 of them would be called exterior angles. Actually with the triangles. You got to have, the exterior angle has to be joined to the triangle in this manner, okay? If the angle's got to be supplementary with the interior angle there. Now, I got to go in there. Over here we have 2 pretty far away angles that don't really seem to have any relationship. Oh, but they do. They do so much. These 2 are called remote interior. Remote because they're the furthest away, interior because they're inside the triangle. Real simple. That's the thing about the geometry. So many of the words are so just very descriptive. It works really well in that regard. So what are we going to do? There's a relationship called the exterior angle theorem. I told some of you yesterday, go look that up if you have a chance to. Google it, see what's going to happen, or see it in your textbook. These 2 angle measures are going to add up to give me this one. You say, oh, wow, that's pretty crazy. Well, let's see what happens when we do that. We're going to put 46x plus 6. And then we're going to tack on, it looks like, are we ready for this? 18x plus 4. All right, those 2 measures right there. And over here, we're going to have that set equal to 70x minus 2. And you say, Ernie, what's going to happen with this? Well, let's see. First of all, let's simplify a little bit. These 2 come together, 46 and 18. Oh my goodness, I always get a little bit nervous about these things. 46 and 18 looks like we're going to get a 64x. All right, you want to check that? Let's check and see that. It's either 60, I believe 64x. Let's do it, calculator. I don't want to get in a mess like this and we don't have the right numbers here. So we got 46 and 18. Kick it out here. I'm seeing 64, which is nice. I did think it was going to be 64x. We got a plus 10 equaling over here to what? 70x minus 2. Already it looks easier. And folks, I'm going to remind you one more time, 844-686-2378 is our number. Let's drop down one more line here. If y'all can drop out my lower third, we're going to kick this thing on in together. Let's go ahead and subtract 70x out of there. And that's going to give me a negative 6x plus 10 equaling to negative 2. So at this point, what we're going to do, yeah, you knew it happened. It always seems to happen that way. Let's break here for a minute because we have a caller waiting for us, all right? And we'll come back and finish this problem up here in just a little bit, all right? So hang in there and we'll see what goes on that problem, all right? Welcome to Mathline. Another caller here. Who am I talking with this afternoon? Are we there?
Yes, sir.
Hey, welcome to Mathline. Who am I talking with?
Carson.
Carson, how are you doing today?
Good, how are you?
Great here. Where are you calling from today?
Sevier County.
Sevier County. All right. What kind of problem have you got for me?
I have a slope as well.
A slope as well. All right. Well, this slope is going along pretty well today. So let's have that one and see what we've got going here then.
-7, -7, and -3, and a positive 6.
All right. I got the right points down there for you. And I'm going to go back, and I use the letter M for slope. That's just kind of a standardized procedure. I always tell my students that S looks like a 5 and it gets confusing, but M is what we use in that respect. And let's go back to that formula I used, rise over run. Are you familiar with that one that we used in our last show, our last problem actually? And let's go with, I'm going to do y2 minus y1 again, all over x2 minus x1, okay? And we're going to, Carson, we're going to just replace numbers in here, all right? We're going to pick up and we're going to say, how about it, 6 minus a -7. And we're going to take that -3 and we're going to subtract -7. So far, does that look good to you?
Yes, sir.
And I'll put those minuses there because they work nicely if we allow them to do so. And this one's not going to be quite as pretty as the last one we had that went through that we were able to reduce down. I think this is just going to look, kind of sit there for us. But let's take a look at it anyway. Adding the opposite, change those signs right there. Those two negatives go positive, right?
Yes, sir.
As do these. So what we're ending up with here is, looks like 13 over 4. If that had been 12, it would have gone down to 3. And when we talk about slope, we can leave it as a 3, but also 3 over 1. But this is a little bit over. Looks like a little bit over 3, like 3 1/4. But we don't need to make a mixed number, all right? So there is what we've got there. And again, as I said to our caller earlier, that simply means that we would rise from, once we set a point on that line, we're going to rise 13, which is quite a bit of rising, and then we're going to run to the right 4 because they're both positive. Does that make sense?
Yes, sir.
Does that work for you? So really and truthfully, it's basically your formula, watching your signs, okay, and being careful, all right? And hey, thanks for calling in this afternoon, Carson, all right? Couple of slope problems. That must be the problem of the week out there, kind of thing, in the classrooms and all the 8th grade and 9th grade classes, learning how to do slope of a line, by the way. So I understand I have another caller waiting. Welcome to Mathline this afternoon. Who am I talking with?
Hello, my name's Dawson.
Dawson, is that right? Okay,
Yep.
Dawson, how are you doing today?
I'm doing pretty good today.
Great. Good to hear from you. Where are you calling from, by the way?
East Tennessee.
East Tennessee. All right. Sounds good. And what kind of problem have you got for me today?
It's a graphing problem.
Okay. All right. So let's hear what we got then. Tell me what's going on here. We'll write it down and we'll get some graph paper up here and work on it.
All right. 3x minus 2y equals 6 using slope-intercept, using the slope-intercept form.
Oh my goodness. There's that word slope again. This must be the day of slope around here. So maybe I need to do a whole show on slope coming up here. But I digress a little bit. Okay, Dawson, first of all, let's go back over what slope-intercept form is, because that's what we're looking for, right? And then we're going to graph. So in order to do slope-intercept forms, my friends out there, everybody's watching and wanting to know, what is that about? We basically need to isolate y by itself. We're going to get the variable y by itself. This is what we call a standard form, all right? 3x minus 2y equals 6. It's got its purposes. It's really great when we solve systems and do other things. But for slope-intercept form, that means we're going to get y by itself, and that's really a nice way to graph. Although we could graph using this too, but since you asked me for slope-intercept form, I give you slope-intercept form. Is that a good deal? Good deal for you there? All right. So let's move the 3x out of the way. Let's move that 3x out of the way because we want to get this 2y. Remember I said we were going to get y by itself. So this 3x is messing that up. The minus 2 is messing that up. So one step at a time, let us take care of getting rid of 3x. Is that okay? You got it?
Okay.
And see what happens. If I have 3x's and I take them away, guess what? I have nothing left, right? Nothing left except minus 2y. Now, to you and our viewers out there, do not lose that minus 2. It's very easy to see this cancel and, oh, take that negative. Nope, that negative belongs to 2y, and it's not moving yet. It's going to move in a little bit, but not yet, all right? Over here, Dawson, got to be careful again. Does this 6 have an x? Does this 6? It does not. So I have to write like this, or I could also put negative 3 plus 6. And I'm going to actually do that. I'm going to put negative 3x plus 6 because, let me just kind of line out here. We're going to create the slope, and then we're going to get the intercept. That's why we call it slope-intercept form. So we want to put it in that order right there. Now, why I emphasize that is don't come up with 3x. If you don't have 6x's and take away 3x's, you just got a number 6, and you've got a minus 3x, and you can't make 3x out of that, okay? So what we're going to do here, we're going to divide everything by negative 2. Now you say, Ernie, why did you do that? Because what am I trying to get by itself again? What letter? I'm trying to get the y, correct?
Yes.
So that's going to cancel. This is going to give us 3 over 2x. Well, that's fine. That's one of our other Euler slope here earlier we had. And here we have minus 3. So what does that tell me? That tells me the slope equals 3 halves. Our point is at 0, negative 3. That's the intercept, all right? So this little tidbit right here, this tells me a lot. Tells me how I'm going to get to the next point. This tells me where I'm going to start. So if we keep that, can we take away just a second for me, guys? And I'm going to bring a graph page in here, all right? Thank you. There we go. They're good today. They're working so hard up there. End of the week, they're ready to go home too, I believe. But we've still got a little bit more to go here. So let's graph this little thing. And the thing we've got now, my friends, is y equals 3 halves x with minus 3, all right? That's where we left, right, Dawson? Is that correct? Is that what I left you with?
Yeah,
and I said we got a slope here, and we've got this point 0, negative 3. So this is our starter. This is going to help us finish. So let's start here at 0, negative 3. Right there it goes. There's your starting point. And notice it's on the y-axis. That's where we start. Don't go over here. That will be bad news because this says go nowhere on the x, go down 3 on the y. So there's your starter. Now, this is going to be that rise over run business. So we're going to rise 3 and run 2. All of a sudden, things are looking good. Do it again, just for good luck, I think, or to make it look good. And here we go. Slip slide away. There we go. Bring back Curious George for an encore here today. And we've got those lines line up. That's what they're supposed to do, isn't it? And there we go. So it's a nice straight line. And there's your graph. That's what it looks like. Does that seem good to you?
Yeah, that makes sense.
All right. Well, good deal. And there we have it. Anything else you need to know about it?
Well, there is a bit of a two-part question. The next part asks,
Okay.
does the point 6, 7 lie on the line?
Okay, real quickly on his second part of the question, you go back to the original equation here. Put in a 6, put in a 7 there. That was the points, right, Dawson?
Yes.
So we got 18 minus 14, which does not give me 6. And guess what? If it does not give me 6, that means that point does not lie on that line. Does that make sense?
Oh, yeah, that makes sense.
All right. Hey, thanks for calling us this afternoon. I understand I have a caller waiting on the line. We are just out of time. If you will hold on, I'll answer your question in the studio, okay? Can we do that? Got that? And tell him I apologize or her for not getting them on the air today, but we'll still take care of the problem. Hey, it's the weekend, right? Coming up. Check out specialized segments tomorrow. Have some fun with us. And you know what? We'll see you again live next week. Again.